Can anyone please confirm whether the slide is visible?
Excuse me, sir. Can you hear me?
Yeah, yeah.
Sir, I will try to connect again after 15.
Hello. You are not audible listening. Jatin, can you confirm? Am I clearly audible?
Yes, sir, you're audible.
Okay. Arpan, your voice is also breaking. So, Madan or Jatin, can you please unmute yourself and say whether I'm clearly audible? It may be Nishan, someone, somebody. Because Yasmin is not audible. Madan, can you please unmute yourself?
Sir,
Yeah, Arpan. Arpan, say it.
yes, you are, you are also audible, sir.
I am clearly audible.
Yes, sir, you are clearly audible.
Okay. Is my screen visible?
Yes, sir,
Okay.
visible.
Okay. So I'm starting the session. When others will join, I'll try to get them in. So this is week 8, uncertainty in AI and Bayesian network, correct? So this week you must have read about uncertainty in AI and Bayesian network. Last week we had discussed about the logic, propositional logic, and there we discussed few problems, how to solve them from theoretical to implementation background, how we to go ahead with the problem by understanding them, denoting them in terms of variable, and then processing over the information given to get the desired objective what has been mentioned in the question, right? So this thing we have done it last week. Now we'll now deal with the uncertainty in AI and Bayesian network of this week. So if I say uncertainty, everything is uncertain. Now I am talking with you. After 5 minutes, whether I'll be able to talk with you or not, this is not certain. Maybe my internet got disconnected. Maybe something happened with the electricity or something like so and so forth. There is a chance that I may not continue the this talk. So there is always a possibility that there is this possibility of both to continue the session, or maybe I'll halt the session in between because of some unforeseen situation. There could be a possibility, right? So as Professor mentioned, Professor has mentioned in the session, everything in real world is also uncertain. We don't know whether that will happen or not. We have some belief and we can say this may occur. You cannot guarantee that this is going to occur. So you have some confidence, you have some probability to say, yeah, this might happen. True. So for example, just recently I coughed. So what does that mean? Does it means that someone has throat cancer? Chances, if I ask someone if someone has cold and cough, does that indicate he or she has throat cancer? No, it seems like you say no, it may not. Most likely it may be a simple cold and cough, something like that. Maybe seasonal, maybe viral thing had happened, something like that. But there is a chance also that he or she has the throat cancer. This is also one possible thing, but we are more likely to say no, he or she may not have throat cancer, because the likelihood of throat cancer is significantly less than viral fever or something like that. True. So just one announcement, here in IIT Patna internet connection is very weak, so I may get lost in between, so and that's why I'm used to confirm whether I'm clearly audible or not, so that to make sure that we are on the same page. So please, someone maybe be volunteer of the session. Whenever I'll ask, please respond, because if you not respond, I'll not get the input. I have to go back and forth, and like that it will get interrupted. So Am I audible? Someone can you please confirm?
Yes, sir, you are audible.
Okay, okay. So, did you get the idea of what I was saying about the cold and cough? It may not indicate throat cancer, it may be viral fever. Like, for example, what is the probability of being earthquake in India just after an hour? If I say there is a chance that there will be an earthquake, most of you say no, there is no chance, there is no chance, there is no chance. There is a chance, maybe 0.0000001 something like that, and that's a negligible kind of thing. So that's why you are saying there is no chance of earthquake, something like that. So everything in real life also is like a probabilistic. Everything is uncertain. Now you need to model it with the with an extra tool called, it is known as probability. So you give some probabilistic view that this event may occur, may not occur, something like that. So this is how the things becoming going to change in your future lectures. Till now you have read something like a factual thing. If this happened, that happened, like that. So it's more of a logic and things, if A then B, something like that. Now it's time to go in depth and understand what does that mean. We are going to deal with the probabilistic view. Yeah, so so with this motivation I expressed why probabilistic view is very important, because ultimately in AI also you need to model real world problem, real world situation, right? So why not to just see how things are happening and model them accordingly. So everyone, if you get any doubt, question, suggestion in between, please feel free to interrupt me. So it's completely okay to interrupt me, and I can have the discussion about the things what are you going on with things. So in last few lectures you understood about what is knowledge and how it is being represented and how it can be used to answer few things, right? Those things we dealt. So there are three main ways to represent knowledge. One is the KR, knowledge representation language. Ontological means kind of a graphical thing, structural thing, and the epistemological commitment, like a Boolean thing, true, false, and unknown, something like that. So in KR language, you read about the propositional logic, first order logic, and temporal logic. Sir, we can discuss the last week assignment. Last week assignment I already discussed. Esneen, you didn't join the session, I remember. So
I don't this week's assignment. How do I say? What was the last assignment which we got result on Wednesday? That assignment.
Oh, I usually don't do like that. I used to discuss, this last week I have discussed about these things, provision logic and satisfiability. So this week I'll discuss about uncertainty and Bayesian network. Some
No,
question.
assignment, which was answered on Wednesday.
Yeah, I was talking about these are the assignment question, right? These were the previous assignments questions.
Okay, so but the session starts at 7, right?
Yep.
Then how did you discuss all this assignment within 15 minutes?
No, this has been discussed in last week. This session, the current session is focusing on this one, week 8, uncertainty in Bayesian network. So this is your current week. So what usually I do, I discuss about the few important concepts about this week and few problems, solve workout sessions. So this is what I used to do.
I think, sir, you didn't discuss this one particular question, which was about the epistemology and the ontology of propositional Bayesian propositional logic and logic first order logic, in which the answer that was given to us by NPTEL team is that they are similar in one case and they are different in one case. But in the first lecture of our Professor Mausam, he said that both Bayesian propositional logic and first order logic are different in both epistemology and entomology.
So you are
So can you
saying
like
which week are you talking about? So actually that's not clear to me. And so you are saying what Professor Mausam said, and whatever the answer is given, these two things becoming contradictory, right? Something like that.
yes, sir, I'm saying that.
So it is about week 7, right?
Yes, sir, it's about week 7. Uh, it's about
Which week? Can you precisely tell?
okay. This is
Because
week 7,
currently
question
I'm
number
not.
9.
Okay, week 7, question number 9.
Question number 9.
Okay, okay. So I'm not directly going to that question. First, I'll discuss whatever I have prepared for this session about, and then if time passes, I'll discuss about that. Otherwise, you can always message me, email me. I'll give you the answer why it has happened or like that. So,
Okay, sir.
yep. So I was talking about the knowledge representation. Finally, this week we are going to define why probabilistic view was required. I told you, because in everything there is an uncertainty, so that needs to be modeled and processed accordingly to have clear view, to have how information has been represented, information used to be represented and processed. So need for reasoning and uncertainty why. So as Professor Mausam pointed out, the world is full of uncertainty. It's totally, I cannot be, I totally agree with it and say, yeah, this is true. So we need to have probabilistic view about the things, how it happens. For example, as I give you an example, so there might be an earthquake in next 15 days. So most likely you'll say, no, there is no such chance. But there may be some event may happen and it may lead to an earthquake, right? So how can we if I model those things and then process accordingly, that we are going to discuss about this session. So probability, as all of you know, I'll not go much in detail, but I'll where formulation is required, where things those concepts are required for solving problems, I'll discuss them thoroughly so that you can answer those questions correctly. Probability, all of you, that the chances of occurrence an event. So I used to give this example in most of my probability lectures. So will it rain today? Should I go with umbrella or not? Something like that. So you may say no, you may say yes. So depending on 2-3 factors, you say you should go with umbrella or not. Until unless you are a Bengali person used to have umbrella always, whether it's rainy season or not season, right? So there are a few factors, for example humidity and temperature, and finally you say based on these things most likely rain will not occur, but you are not quite certain. You may say okay, with the 0.99% probability the rain will not happen, please don't carry umbrella. So based on that temperature and humidity, you think about what has happened in past. With this temperature and humidity, has ever rained or not? Something like that. So randomness is the fundamental to the universe and you need to model them. So tossing a coin, whether it's a probabilistic or deterministic, who will say? Someone can say whether it's a probabilistic or deterministic. You must have heard in this Professor Mausam lectures. Is it probabilistic or not deterministic? If I toss a coin, will it be head or tail? Can you say with certainty? Please say someone.
It's probabilistic, sir.
It is probabilistic. Okay. Yeah, we model it as a probabilistic, but the way the coin is tossed, the angle, the thrust you provide, the height. If everything you model it, it's most likely it's a deterministic. If you control every physics and controllable, if every factor, temperature, wind force, and everything, that's a more likely it's a deterministic. With all these
Yes, sir.
factors, if
Yes.
you know coin it, most likely it will come with the same thing. So that this is one of a view how you see the things. Probability is a mathematical framework for identifying uncertainty and then model the world accordingly. So it's a number of favorable outcomes to the number of. So this slide says everything about how machine learning, how classical machine learning to deep learning has went through. Initially, we started with the table lookup, then we went to the rule-based system. Table lookup is you have table. So when I say what will happen if temperature is 10 degree, whether it will rain or not, you have a lot of data. You went to that row and said no, the rain will not occur. So this is a kind of table lookup approach. Next comes rule-based system. You have a lot of rules and you pass your inference sample to it and say whether what will be the outcome. So for example, I said temperature 10 degree, you will pass it to some algorithm and it says okay, if temperature between 10 to 15 degree, most likely rain will not happen, like that. Then comes to the statistical machine learning. Statistical machine learning is your frequency based thing. So with this temperature and how much time it rained, so if it is greater than some threshold, you will say okay, it's most likely it will not rain or rain, something. Now comes to the neural network. You just give data, let it be the all the data, it will figure it out, understand the meaning out of it and see what does that represent. And finally yeah, so I was talking about the how we went from statistical machine learning to neural network. So from in neural network, if you just give input in raw form, you can expect output. So that raw form input is being processed inside the neural network itself. Whereas in traditional machine learning, you give features and then finally it is being processed. So how in last 20 years has been processed table lookup to neural network things. For example, sentiment classification, I'm glad to get this opportunity. You just, if it is a statistical machine learning, you represent I am get good all with some bag of word or TF IDF, then give it to model and then model will say whether it's a sentiment positive, negative or neutral. But in neural network, it says, okay, don't do everything. You just give me text as it is. You give me input in the raw form. I'll get the task done, whether it's a positive, neutral. So feature engineering also happen inside the network itself. So just everything about this. So it's about data and output you give, and it will give do the program itself. But here, in machine learning, it needs human engineering. It needs features. This data is not in raw form. It is in some processed form. But deep learning says, give input me itself. I'll do the feature extraction learning along with. So you don't have to do something human engineering or some feature engineering like that. I'll do inside myself, the network itself. So how machine learning and probability is relevant? Every time you give something to the machine learning, it is just calculate the probability of that outcome. As I said, for that sentiment classification problem, given it just do what is the probability of given that sentence, it is being positive, it is being neutral, and it is being neutral, negative and positive, and just do arguments over it. Which one is the more? It says this is the sentiment of that sentence. So probabilistic and machine learning goes hand to hand. So you cannot think it as two different things. It's just two sides of coin. It's just a statistical machine learning is being given in another form. The deep learning is like that. So you need to understand probability in detail, so that's then only you can understand things in very depth, and you can reason about that. You just don't do inference and all those things, but you can say how input is being converted into output. So as I said in most of my lecture, what happens in any model is you give input I and you expect output O, right? So I is being passed to a network, it is becoming I dash. It's hidden representation of that I. It's a featured or intuitive representation of the I that easily maps that representation to output. So think it as like that, I dash and O. So here also you reduce your I to I dash in such a way that so that you can easily map with the O, and O is nothing but probability distribution over given outcome space. So when you say I am eating cake, so there is a chance that the probability of being sentiment positive is huge, because but it's becoming also neutral. So it's probability is nothing but a confidence how you are saying about your outcome, right? So these theorems and everything you are most likely to know, but still I'll discuss them because the foundation is about how you define probability, then conditional, then Bayes theorem, and this whole week depends on these things only. So these are important concepts that you needs to know. If someone can answer, I'll go ahead and easily and go about that. So a six-sided die is rolled twice. What is the probability that the sum of the number is at least 10? So how you will solve this problem? If someone can attempt, it would be good to go. A six-sided die is rolled twice. What is the probability that the sum of the number is at least 10? So you first find out the sample space. Sample space means what are the possible outcome. So if you are throwing two dice, the output could be 1 1, it could be 1 2, 1 3, 1 5, 1 6, right? Likely you wrote it, enumerated all the possible combinations, 6 4, 6 5, 6 6, like that. And finally it is saying the sum should be at least 10. So you are finding the events where sum of two number on the dice is 10. 4 6, 5 5, 6 4, 5 6. Oh no, not should be 5 6, it's wrong here. It should be 5 5. At 6 5 it should not be there, 6 4 it should be. So it's greater than 10, then it's true. I thought it should be 10. So all you events, you just took it which sum is greater than 10, you enumerated here, and then finally number of such events are 1 2 3 4 5 and 6, and total number of events in sample is 36. So 6 by 36, which will be 1 by 6. If I take this problem and ask something differently, let us see if someone can answer or not. So just in one go, can someone say what is the probability? The same question, sum should be less than 10. Hello, am I audible, Madan? Or Esneem? What is your name? Esneem, I forgot.
Yes, you're audible, sir. My name is Swarnim Maheshwari, sir.
Swarnim Maheshwari. Okay, Swarnim, so what will be the probability of number being less than 10?
Sir, actually, I don't have a pen and paper here at the moment.
You don't need pen and paper, I guess. It's a one go answer. Can other also attempt? So you have two dice, you thrown it. What will be the Probability that the sum should be less than 10. Can anyone attempt? Please do attempt, you will get some bonus kind of thing. I don't know why you
Sir,
do
it's 1/6. I'm not like, I'm just like,
Hmm.
so it's the probability, like, let's first consider that the first die comes 6.
Hmm.
So that is 1/6.
Hmm.
And the second die has only four possibilities, that it will either come 5 or 6. So two possibilities. So it's 2/6. Plus, if 5, if the first die comes 5, then the second die has three possibilities. That is, the if the first die comes 6, then the second die also have only two possibilities.
Hmm.
Only one possibility, 1/6.
Hmm.
So it's 1/6 times 1/6. If the first die comes 4, then the second die cannot, the sum cannot. Okay, we are taking equal to 10, right? Equal to, greater than equal to 10,
Yeah,
right?
I asked the question this one. So there is a text box, I wrote it here. So sum should be less than 10, rather than here we calculated
Okay,
opposite.
so I will just minus, okay, less than 10, right? Okay. So 1 minus 1/6 times 2/6 plus 1/6
Hmm.
times 1/6,
Hmm.
that will be equal to, I don't know, 1 1 2 6 36 plus 2/36, 36, 36 minus 3/36, this goes 33/36.
Hmm. Hmm. How much? It is becoming 0.00 something.
Yes, of course.
How much?
Hello.
Yeah, yeah. So you are saying 1/6, 5/6, 3/6. So it seems like the way you are reasoning is correct, but this is not the way you need to solve it. So it's a very simple problem. Here we calculated n should be good, sum should be greater than 10. I ask you less than 10. It's just 1 minus of n of sum greater than.
Yeah, that's what I was doing, right?
That if that's you have done, you could have told the answer in just a second. So it's a 1 minus 1/6, which is 5/6. So this is the problem I have observed with the people. They just don't try to understand the concept. Say, why don't you solve the assignment problem? You need to understand how things are being solved. If you don't understand the concepts, you need to go back and have to refer it again. So that's why I used to focus on concept and then do the problem solving session. The other Ts also have pointed out similar thing. So it was as simple as that. Here we calculated sum should be greater than 10. It's, I ask you sum should be less than 10. So 1 minus 1/6, whatever calculated, because probability is finally becoming 10. Probability of these two things should be summed to 1. So it's 5/6. Anyone have any doubt, any question? Is it clear, Swarni? Hello. Madan or someone else, can you please confirm whether I am audible?
Yes, sir, you are audible.
Yeah, so Swarnim's he is on mute, so might be he is calculating. Okay, so this is how things works. Now coming to the conditional probability. Initially I talked about what is the probability and all those things. So this kind of question going to come in your April exam. When is exam? Exam date is already announced, I guess 28th of April, if I am not wrong.
29th, I believe.
29th, okay. 29th will be, so please be thorough with the previous year questions as well. All assignments, if you will solve, you will have very clear. We will also do those things. So in upcoming session, we will try to solve assignment question as well as the previous year questions, whatever has been coming. NPTEL 2022 exam or 21 exam, something like that. So now coming to the conditional probability. Conditional probability is very important because in machine learning you give an entrance and say whether it's a positive, negative. So given an entrance whether it should be positive, negative, or neutral. So it's a conditioning on some input, right? So here conditional probability is initially we are calculating P of A, let's say, which was number of favorable event for A by total number of events. Here we are giving extra information. You calculate P of A, that's fine, but I'm also telling something about other events. This has already occurred, this has not occurred. Then you calculate this information. For example, if I'll say in IIT Patna one event is happening, there is a concert of, let's say, Sunidhi Chauhan. What is the probability I'll attend it? You are not sure about that, whether I'll attend it or not, right? And if I'm not someone to attend this kind of event, the probability would be less. But if I also give that information, I am a great fan of music, your probability will get changed, right? If I'll ask what is the probability of I being to attend this Sunidhi Chauhan concert, given the information I am a big fan of music, your probability you will say that there is a chance, there is a great chance I'll attend the event because I have given you the extra information that I am a great fan of music. So here also we have, and by the way, it's true in IIT Patna, our annual phase is happening. It's Anvesha, but this is not the fact that Sunidhi Chauhan has came, someone else has came. So I just was able to correlate with it. So P of A given B is intersection of these two events. These events occurred together by evidence that P of B has occurred. So this P of B is known as evidence, and P of A intersection B is a joint probability that these two events has occurred. So just giving an example, sentiment of an utterance masses versus sentiment of an utterance masses given its emotion information. This is very, so as I say, finally with the AI, these concepts you need to solve some problem, right? You need to make a model that will solve some real world problem. So just giving a real world example, sentiment classification, emotion classification. So if I am saying the emotion of this utterance, let's say you is happy. If I ask what would be the sentiment would be positive, negative, or neutral, what would you say? All of you will say most likely the sentiment would be positive. If someone emotion is happy, the sentiment would be positive, it's more likely, right? So so this extra information gives you some more clue. If you can understand this this sentence, it will be very easy to understand the conditional probability in them. Conditional probability, the condition which we give, it just restrict down the sample space. I repeat, with the given condition, sample space is being reduced, and you get easily you calculate finally event probability based on that reduced sample space. So this is the difference it makes. Another example, so I was thinking, rather than giving solution, if someone could solve, or I can solve in front of you, that would be more easy, but okay, let it go. So problem statement is this, and by the way, what has happened in last few weeks, so what I was doing, I was taking the previous year assignment, not this year 2023, because I used to teach currently and then discuss the previous weeks. So I used to take previous year assignments and I used to solve them. But this week we didn't get this assignment. Last week 2022 we didn't get this assignment. So that's why I have to take some running samples and showcase the things. But these kind of things which will come in there. But as Swadnim or someone also has pointed out, I'll also solve the other assignments provided in your this session as well. So that needs to be solved. And also I was planning to have, I'll give you some YouTube session, not do the online because I already missed few sessions. So there I'll give the all previous year questions or this year assignments. I'll solve it out and give you the link. in the public sector. Yeah, so let's come to this problem. Consider an example of rolling a die. If A is the event, the number of appearing on, B is the event, that the number appearing is a multiple of 3. Verify whether these two events are independent or not. So what do you mean by independent? So can someone define with the concept of conditional probability? Please do interact. Please say answer, otherwise it seems like I am the only one who is talking. So this is the main, objective of this session is to you interact, say something about the problem, interact and get your doubts clear. So my question was very clear. I am saying, can anyone define independent, what are the independent events? And second thing, in terms of conditional probability, it's very easy.
So independent events are which do not affect each other. Like knowing one event does not affect the probability of some other event. These two events will be called independent events.
Perfect.
That is the conditional probability of some event. Conditional probability of some event, some given event, given that some other event is equal to the probability of the event.
Yeah, true. So the both definition, whatever he gives, correct. So he said independent event means two events whose probability don't affect each other. So that's true. In terms of conditional probability, he said probability of A given B is probability of A. It doesn't matter whether what information I have given about the B. For example, Narendra Modi is in Gujarat, and if I ask this information, given that Narendra Modi is in Gujarat, what is the probability today I'll go to the concert? More likely these are independent, until and unless so much connection if we'll find out internally. Otherwise these two events are independent to each other. But if I say it's raining outside, what's the probability of me going to concert? These are two dependent events. In rain, most likely I'll not go outside, so it will reduce your probability of going outside, right? So these two events are independent. So you should have very clear idea about dependent and independent event. Finally, this is how you are going to model Bayesian Bayes theorem and all concepts. So dependent and independent is a very important concept. So please take it thoroughly. And so question was, verify whether these two events are independent or not. So what are the events? Events where the number being appearing is odd and the number appearing is a multiple of 3. So there is a property, an important property of independent event is that their intersection, P of A intersection B, if you calculate, it will be equal to multiplication of these two events. So probability of occurring A and B together will be equivalent to multiplication of P of A and P of B. This is an important aspect of two independent events. So if I'll ask you to verify whether these are independent, you just check this theorem whether it works. So this is what here it has been done. So throwing a die, the sample space would be, there is a chance it will come to 1, 2, 3 or 4 or 5 or 6. But when I throw a die, it seems like there is nothing like 5 and 6. Most of the time it comes to 1, 2, 3 only. So, but universal space is 1, 2, 3, 4, 5 and 6. So, what is the probability of being as an odd, which is A? So it is A 1, 3 and 5 are odd numbers. So this would be the sample space. For B, the event space would be 3 and 6, multiple of 3. Now probability of A would be 3 numbers are there and total numbers are 6, so 3 by 6, so 1 by 2. P of B would be 2 by 6, 2 numbers are there and total number of are 6, so 1 by 3. Now you are calculating it. What would be the P of A given B and P of B given B also you can calculate and see what it is doing. Right? So this is one theorem about the conditional probability. Please take it. P of A given B is equivalent to P. We just discussed P of A intersection B by P of B. That's we are going to use it here. So which is here we are calculating P of A intersection B with this theorem. If I'll say the number is multiple of 3, what is the probability it is an odd number? Can someone calculate? Yeah, my question was, you know that it's a multiple of 3. So P of A given B, we need to calculate P of A given B. We need to calculate B. You know that whatever the number has come on the dice, it is a multiple of 3. What is the probability it is odd? This is you need to find out.
1 by 2. 1 by 2.
Yeah, that's one way to how it comes.
There's only two possibilities, right? It's either 3 or it's either 6. 6 is even, 3 is odd. That's 1 by 2.
Yeah, so he is saying P of A given B means you know that A has, it should be A has occurred. I am saying given the information B has already occurred. So 3 and 6 is in order dice. What is probability? It is an odd. So here two numbers are there, 3 and 6, and one is odd, 3. So it's a 1 by 2. So it's coming to the same definition I said to you. If you see conditional probability is just reducing your event space, sample space. So there was a chance 3 and 6 both would come, but you already said the information that this is an B. B you already told about. The B is that it is a multiple of 3, and you are asking whether it should be odd or not. So it's a only possible thing could we have is here 3. So it's a 1 by 2 because two numbers were there. Finally, we calculated A of B. Now, with this information, we are interested in this region. What will be P of A intersection B? So, if you have this information, this is 1 by 2. You just multiply with the P of B, then you will get this information. And P of B is what? P of B is 2 by 6, which is 1 by 3. Right? You just multiply and check. Let's do it here. So, we are interested in calculating P of A intersection B. I don't know how to do intersection. Let's write it here. Intersection B, which is P of A given B, P of A given B into P of B into P of B. So it will come to P of A we can give, we calculate it's 1 by 2 into P of B. P of B is already we have 1 by 3. 1 by 3. So finally it turns down to 1 by 6, right? So we calculated that the P of A intersection B is 1 by 6. Now you are going to multiply and check whether these are true or not. So it is coming that if you do that P of A and B, it's 1 by 6. So intersection becoming equivalent to multiplication of this, right? So these are independent event. So which implies the occurrence of event B has nothing to do with event A. So these two events are independent. So this kind of question will come. For example, rain and let's say temperature. They'll give some sample point and finally ask whether these two are independent or dependent event, and you need to answer. So there is an important concept you must have heard. In a bucket you have lot of balls, you are removing one by one. So there are two concepts, with replacement, without replacement. So you can remove one ball in two ways. You removed it, but when you are calculating new probability, you just put it there. So with replacement and without replacement. So here that's this concept I want to make it clear. That's why I'm giving this example. So 2 blue and 3 red marbles are in the bag. Right. So this is a scenario. You have 2 blue ball and 3 red ball. What is the probability? If I take one red ball, your sample space will look like this. If I take one blue ball, your sample space will look like this. So what are the chances of getting a blue marble? Obviously there are only 2 marbles, so you will have 2 by how many marbles are there? 5. So 2 by 5. But after taking one out, what will be the chances? So as I said, there are 2 possible. If you got a red marble before, so the chances of blue marble is next is 2 by 4. Why it has happened like that? It is saying, but after taking one out, the chances changes. Obviously the chances will change. If you are taking one ball out, there is a chance that was blue, there is a chance that was red. So here we assume that whatever you have taken out, this was the blue. Here you assume whatever you have taken it out, it was red. Whatever. So the chances of blue here would be now 2 by 4, and the chances of blue here would be 1 by 4. Did you get the idea of what I was saying? So it's pretty simple. If you are replacing something, your sample space being changed, right? If you, I said let's remove one ball, one marble. I did it here. There is a chance it might be red or blue. So I considered both the cases. In first case, I considered whatever I had removed, it was red. So now sample space would look like something like this. And the chances of blue marble here would be, you have 2 marbles, so it will be 2 by 4. Total number of marbles. Here it would not be 5 because only 4 marbles are there. Similarly, you have taken out one ball and that was, let's consider it was blue, then your sample space would look like something like this. And the chances of now for taking out blue is, there is only one blue, so 1 by total number of balls, 1, 2, 3, 4, so 1 by 4 will be there. So please, whenever you solve some problem, something will come look like that, please consider that what has been told, that these things becoming tricky. When if you give 15 minutes and solve it, you will get some other answer if you don't consider things very thoroughly, with replacement, without replacement. Sometimes it says without replacement, with replacement. So these things, please take care of it. Now coming to another example. In a card game, suppose a player needs to draw. How many of you know how to play card? I think most of you. If not, then we'll take another session to teach you out about the cards. Because in a card game, suppose suppose a player needs to draw 2 cards of the same suit in order to win. Fine. Out of 52 cards, there are 13 cards in each suit. So there are total 52 cards and 13 cards are each suit. Suppose the first player draws a heart. Now the player wishes to draw the second heart. What is the probability of picking a second heart? It's pretty simple. So the problem statement is that there are 52 cards, and let's say there are 4 colors for simplicity: red, blue, green, and yellow. So 13 cards are there for each color. Someone has already picked a heart, let's say red one. Now when picking, what is the probability in next go he'll get again heart? This is the question. So we have in total 52 cards. So whenever you solve some probability question, express in terms of numbers, express in terms of variables, you will get very easy. So this is how your sample space look like. It is something like, let's say 13 red, 13 yellow, 13 blue, and 13 grey. It's not Ludo, but I made it like a Ludo. Yeah, same color, red, yellow, blue and green. Blue and green, yeah, true. So it is saying, what is the if someone has already picked one rate. Now your sample space, how it will look like? Your sample space will look like 12R, 13Y. Let's copy it y to y. Your sample space will become something like that after taking one red one, and red one is, let's you consider it as a heart. If I'm asked, well, now what is the probability of picking again heart? It's, you have 12 samples, okay, so it is like favorable events 12 by how many events are, how many cards are there? 12 plus 13 plus 13 plus 13, which would be 39 plus 12, which would be 51, right? So this one would be your answer, correct? So this is how you solve one problem in probability and stats. If I ask some other question related to that, let's see if someone can answer it or not. What is the probability? That's interesting. You people know ASCII code, right? So if I say you have ASCII code for R, Y, B and G, that, and now you are going to pick two events, not one, two at a time. What is the probability that ASCII code of these two events, E1 and E2, let's say, whatever the character you will get, the sum should be greater than, let's say, 56. Oh, ASCII code started with 65, if I'm not wrong. For A it's 65, how it could be 56? 100 would also not work. Am I correct? ASCII code for A is a 65? Oh, you people are from computer science now. Please say what is ASCII code for capital A? Yeah, for lower case it's 97. For higher case it must be some, not 65. Yeah. Oh, that's great. I was right. ASCII code for capital is 64 itself. Now, let me confirm whether I am audible or not. So, Nishad, Swarnim, am I audible?
Yes, sir, you are audible.
So, are anyone trying this question? So it was sum of ASCII code for these two events should be, let's say, 120. Yeah, like that. Just tell me how you are going to approach this problem. So question was that in, let's say you have 52 cards, 13 for each shoot, let's say red, green, blue and yellow. I'm saying you're not going to take one card. Let's say you are going to take two cards. And I'm asking the ASCII code for these two characters should be greater than 120. How are you going to solve this? This is problem A. Problem B, let's make it more simpler, that it should be of same color. Would be same color. Yeah, these two things are there. So someone first tell about this same color. It's easy. Huh?
Yeah, 25 upon 51 for same color, right?
How much? 24 upon
25 upon 51.
25 upon 51.
because 13 of the same color of other suit, 20 and 12 of the this same suit, because one card is taken out, so only 12 is left. 12 plus 13, 25, and there are 51 cards left because we all took out one card. So 51 cards. 25 upon 51.
Oh, really? I don't think so. You just think with intuition. You have 52 cards. I'm saying you are going to pick two cards at once. And what is the probability that
Okay, so
they
you are
should be
going
of same
to
color?
to card simultaneously.
Yeah, yeah,
Oh, and what is the probability that they are of the same color? Okay,
yep,
okay,
yep.
okay. Hmm.
You are saying it's for this one. It's the
Say
same.
the first card, let's say the first card is of black color, that is 1/2. Then the second card will be of the black color. Will probability will be equal to 25 upon 51, and we multiplied this entire thing by two. Same answer will be same.
Oh, you are saying answer would be 25 and 50.
Yeah, answer will be same. It will be 25 upon 51.
Okay, let's see. What others say? Someone else? Just think about it. This is the wrong answer, by the way. So, what did you say? You have 13 cards for each color. Right?
30, as in 30.
No, no, 13.
No, we have 26 cards, right? Of each color. One of black of spade, and then black of, I don't know what it's called, but we have 26 card of each color, right?
No, no, we are discussing this problem. No? I have already written it clearly that this is how your sample space will look like 13 red, 13 yellow, 13 blue, and 13 green.
But that's not how cards are made. But okay, okay. Uh,
Yeah, true, that's not how cards are. That's why I was converted it as like a Ludo problem. Now you attempt this one, so you have 13 for each. I'm asking you are going to pick two cards at a time. What is the probability it is of same color? Anyone could attempt solve it. I am giving you 1 minute and then say how it will solve.
this will be 12 by 51.
This would be 12 by 50. Let's others should also do. And you make sure that whatever you said. Oh, initially also you told 12 by 51 or what? No, you said 25 by 51. I'll randomly ask you some, please have at least some intuition that how it could be solved. Anush, can you tell how to solve this problem? The question was, you have 13 cards for each color R, Y, B and C. Now I'm saying you are going to pick 2 cards. What is the probability they are of the same color? Ramakrishna. Hi Ramakrishna.
Sir, all the cards are hard.
No. I just reformulated the problem. I'm saying you have cards and 13 cards for each color. 13 for red, 13 for yellow, and 13 for blue, and 13 for green. I'm saying you are going to take 2 cards at once. What is the probability they are of the same color? This was the question. How are you going to attempt it?
2 by 13.
2 by 13 by Sonia, you say how you calculated this is 12 by 15. Okay, I don't know, he is still on mute, so maybe some internet issue. So I said it should be of same color, right? So what are the possibilities? It could be of red, it could be of blue, it could be of yellow, and it might be green. These are the 4 possible things, right? Now what is the probability it could be of red? So let's say initially it could be red, then it would be 13 by 52. 13 by 52. You took a card, there are 13 red and out of 52, so the probability is for red is 13 by 52. Now you are going to again take a card and it should be of, again I'm saying it should be red. So its probability become, there are 12 cards and out of 51. So it will look like something like that. Plus, now do same thing for blue and the number would be same again. 12 by 51 plus this one plus this one 4 times. So let us reduce it. So it will look like something like this, which is equivalent to 4 into 13 into 4 into 13 into 12 by this number, 52 into 51. Yeah, so it will look like something like this. It will be like this. So if you calculate it, it would be 452 would be cut out, and then finally you will have some number. So it will be 13 into 12. it will be 52. 52 will be cancelled out, so it will be 12 by 51. This is the chance. Yeah, anyone have any doubt? Ask me how I calculated it. Is it clear? Should I go ahead? Anyone have any doubt? Please feel free to interrupt. Okay, now coming to the Bayes theorem. So there was two section of this session. If you see, the title of this week is the uncertainty in AI and Bayesian network. So uncertainty AI is doing a probabilistic modeling that we discussed till now. Now we are going to the Bayesian network or the Bayes theorem, how we are finally going. So till now, any question, suggestion, if you will have, please feel free. Probability is a very powerful tool. So this is how your algorithm or inference is being done. So it's based on data you do the machine learning, nothing else. Your weather forecast is saying today there will be rain. It's just a number, it's just a data, it's just a probability that they have done with the given situation, how many times it has rained. And when it is saying it will be rain, more likely the threshold is greater than 0.5 or maybe 0.7, something like that. So probability is that much powerful. To take any decision, it is being used and do proper modeling based on it. So what is Bayes theorem? So Bayes theorem says it condition probability distribution of one random variable, one event given the other information. So for example, it is here the formula in term how it is expressed is P of H given D. D is your data, machine learning data, and H is the hypothesis. Given the data, what is the probability that hypothesis holds? So this how it is being expressed is in terms of conditional probability P of D. So let's give you intuition rather than going into this formula and telling you. First give some example. So this is, you have data with the temperature greater than temperature less than 5 degree. The temperature is less than 5 degree. This is what is the probability it will rain. So what data says, with the less than temperature 5 degree, most of the time it doesn't rain. So it is more likely this time it will not rain. Let's assume. So D is our data. We'll have lot of data with which is look like, let's say, 2 column, temperature and whether it's rained or not, 0 and 1 variable output. So we are trying to verify the hypothesis. Hypothesis was that if temperature is less than 5 degree, it is not going to rain. This was the hypothesis. Now we are going to calculate confidence over it. Whether whatever you are saying, whether it's a probability is 0.9, then you can say whatever our hypothesis was, it was correct. But if you calculate the probability and it is less than, let's say, 0.2, 0.3 or 0.5 even, then whatever you have hypothesis, it is not good to have. It is not good to be considered, right? So P of D is your data, and H is the hypothesis, it is not going to rain. And data says what it says, H, like temperature. So we are modeling in a reverse way, that it has rained. Now you checked it out, how many times it was temperature less than 5 degree. If you see these two terms, you are able to relate it, P of H given D and P of D given H. Into P of H, I am saying just do the reverse thing. You are here we are calculating in the information D has occurred, what is the probability H will happen. So we are saying no, let's do the reverse thing. It's like a P of H has happened, H, the hypothesis has happened. You see with that hypothesis how many with what probability you can regenerate the data, or you can have the same kind of data, and you are also calculating evidence over it. I'm sorry, not evidence, it's a prior probability, P of H divided by P of D. As I said, P of D is evidence, because you are calculating P of H given D. So D is, probability of D is known as a evidence, you have some evidence, right? And based on that you are calculating P of H. So these terms are very important. What is likelihood, what is prior probability, and what is evidence, and what is post prior probability. Because in the questions whatever you will be given, they'll ask these terms, what are the likelihood, what are the prior probabilities, what are the posterior probabilities, like this. So posterior probability, which is P of H given D, is equivalent to likelihood. With the given hypothesis, you are able to generate the data likelihood into prior, what is the probability of that hypothesis is going to hold, divided by evidence, what was the evidence for which you are going to do that. Again one problem, this is an interesting problem. If I have not given you solution, I don't know how you have attempted. So should I try it without, no, let's see how, because I have some other problems. So the question is that the man is known to speak the truth 2 out of 3 times. If the man will given 3 chances to say something, 2 times he'll say truth. He knows a die, he throws a die and reports that the number obtained is 4. What is the probability? It is actually 4, because he may also say lie, right? So the man he has thrown one die. Now we are asking, he is saying it is 4. We are asking whether it's really 4. We are now about to ask this probability. Please say how we are going to solve it. Okay. So as previously stated, you need to first take a problem and then make it into variable form, so that you can process over it. You can calculate something and based on it. So we have given in form of variable. If you see here, A is, we are calling, the man reports that the number 4 is obtained. This is the A. E1 is the event that 4 has obtained, and E2 is even that 4 is not obtained. So we just given 3 names, A, E1 and E2. Now we'll calculate one by one what is P of E1, E2 and like that. P of E1 is, what is the probability that the 4 has obtained? Forget about the man. So if you throw a dice, only 1, 2, 3, 4, 5 or 6 will come out, no other thing, right? So 4 will happen. What is the probability? It's 1 by 6. If you have to calculate probability of E2, that the event is not obtained, it's just, as I said, it's the sum for these are the 2 contradictory events. 4 has obtained, 4 not has obtained. If you do the sum, because then it will be 1 only. If you throw a dice, number would be less than 3, number would be greater than equals to 3. These are again two contradictory events. If you know one, you can obtain other by doing 1 minus. So P of E2 is 1 minus 1 by 6, which is 5 by 6. Till now it's clear. Now we are going to calculate P of A, that the man reports the number is 4, given E1. E1 is that the even 4 is already occurred. Probability that the man reports 4 and it is actually 4. So it is 2 by 3. Why it is 2 by 3? Can anyone tell? P of A given E1 is that 4 has obtained and the man has already told 4, right? So it's most likely it is the same. I can say it as also that man has told truth, right? So what is the probability that he says true? It's a 2 by 3, because in the first line itself you say a man is known to speak truth 2 by 3 times. So it's 2 by 3. You are asking 4 has obtained and the man has told. So it's a 2 by 3. Now the probability that the man reports 4 but it is not 4. So in some way you can say the man has told, lie. And you can calculate it as like 2 out of 3 times he is saying true means only 1 time he is saying false, right? So it's 1 by 3. So from here we calculated these 3 events. Till now everything good? Fine. So we are interested in calculating that find the probability that the number obtained is actually 4. So we are calculating probability of E1. E1 is that the event is 4. Fine. Given the information A is that the event that the man reports number is 4. It has done because he has somewhere it has written that he throws a die and reports that the number is 4. So with this given information, can we calculate E1? Yeah, let's do that. So it is P of E1 given A, and with the Bayes theorem we can write like that, right? P of E1 given A into P of E1 by P of A. So it's your priority to likelihood by evidence. I think till there everything is good. Now you are opening it with the chain rules. So P of E1 into P of A given E1 by, you are opening this P of A. P of A is what? The event that the man reports that the number 4 is obtained. So you are calculating this information. So everything is okay here till then. If you see, only P of A has been expanded. So how we can expand it like that? P of E1 given P of A given E1, P of E2 given A given E1. Why we have done like that? Can anyone tell? Or with what inference or with what theorem it is being expanded? So P of A given you E1 is what? this is the information that what is the probability that the man reports the number is 4, given that information, P of A is what? The event that man reports the number is 4. How it could happen? There was two way. Either the obtained number was 4 or not 4. So this sum has been the same thing. 4 or not 4. Explain like that. So in one case assume, okay, whatever it was obtained was 4, let's assume. So you have that information that 4 has obtained, and now what is the what is the posterior probability of even has occurred yeah. So I was talking about we are interested in this term P of A. So this could happen in two ways. Either the event was really 4 or not 4. So this term represent was 4 and not 4. So we assume it was 4, P of E1. Okay, you assume it was 4. So what is now posterior of that? Posterior would be P of A given E1. Similarly here it was not 4. What is the posterior of that? It was not 4 and P of A given E2. Now you put the value everything 1 by 6 here we calculated itself, right? P of E1 and everything we will do, then it will comes out to 2 by 7. So this kind of question, definitely one question will come in your final exam and maybe in an assignment, something like that. So you need to understand them how it is being told, because I have seen many times these questions comes true, lie, because people used to get confused in these things. Should I go ahead? If anyone has any concern or doubt here, then I can be for more fun and discuss. Okay, I have a lot of things about the Bayesian things, so I will quickly go over it and discuss few problems on Bayesian networks. Almost time, it's 8:30, so we have half an hour. So as I said, this example already told you what is D and theta. Theta is your model parameter. Given D, you try to estimate theta, right? So you can say it like that. Given D data, you are going to estimate theta, and now you are expressing in terms of Bayes theorem. You people know what is random variable. Random variable is variable you are interested about. So you are seeing over the time how it is, its occurrence probability is changed, is being distributed. So these are all imply. If I say M likes management work, yeah, there would be few person who would like to do management. There would be few person who used to do research work, and out of these all employees, someone would also love to do front end work. What is priority distribution? Over a range, let's say X is your random variable, over whatever the domain it could have, how occurrence of that X happens. This is known as a priority distribution. So in case of, let's say, die, you are going to throw a die, so X could be 1, 2, 3, 4, 5 and 6. Now what would be the Y probability of 1, 2, 3 and 4 and 5, 6, right? Here it would be, everything would be 1 by 6. Perfect. So this is known as a discrete variable. Discrete variable, because you have the event space discrete 1, 2, 3, 4, 5, 6. But if I say something, what will be the probability of X greater than 2? It will be your continuous, right? Because from 2 to 6 you will have. So this is difference between continuous and discrete. Few examples I have given. I'll share the slide and you could have a look, because now I will be discussing about Bayesian thing, because this was the key for this week. Standard normal form. So there I told you two things: discrete random variable and continuous random variable. So with what function you calculate y in discrete random variable, it is known as a PMF, probability mass function. Whereas in continuous random variable, it's known as a PDF, probability distribution function. So this is how discrete function PMF look like, because these are the discrete and these are how the continuous one look like. These are few examples of PMF binomial. Bernoulli should be there. By mistake, it's just written as two times. Probability density function. These are few properties, and this is very important distribution, Gaussian distribution or normal distribution. I'll ask everyone to have a detailed look on it. So there are two terms, mu and sigma, mean and standard deviation. If it comes to 0 and 1, this is known as a standard normal form. Your function would look like this, 1 by root 2 pi and e of minus z square by 2. And this function is very important machine. Most of the distribution look like this, Gaussian distribution. Now coming to expectation. What is expectation? It is a weighted average over all possible x, the domain you have. Right. So for discrete it looks like that, because it's a discrete, x might be some number, so that's why it is given b of I. Fine. For continuous it will be integration form. These are some property. Expectation of x plus y would be individual sum. If it is a multiplication will come out. This is one example, so I'll come back to it if I get time. Very simple one, just putting the formula I'll be able to do it. So it was determine the mean and variance of the random variable x having the following distribution. So you need to calculate it. Data is missing things like, so I need to put it there. Now this part, please concentrate. This is very important. Bayesian network. Till then, any question about probability distribution function or you can ask. Seems like no. So now let's discuss this Bayesian network. So as name suggests, Bayesian network, it is based on Bayes theorem. It is a kind of probabilistic graph model that leverages Bayesian inference, whatever we discussed there, P of A given B. That formula, if you understood it thoroughly, you will be able to solve any problem from here. So I will discuss two problems from Bayesian network. So this is one scenario. It looked like a cloudy. So Bayesian network is like a acyclic graph going from one side. This is acyclic directed graph. ADG is also known as. So you can think it as a decision tree as well. So I don't know whether you have read about decision tree or not. So it's like, it's a cloudy, and the cloudy probability is 0.5 and false is 0.5. What is from cloudy, you can go to either sprinkler or you can go to rain. Now your this joint distribution will look like that. What is C? C is your cloudy. Cloudy, it could be cloudy or not, true and false, right? P of S equals to T means what is the probability that is sprinkle, and what is the probability it could be it is not sprinkler. Now you are enumerating probability distribution in that term. Please try to understand what here it has been done. You are, let's say, standing at a sprinkler. So you are here and you are thinking about either your ancestor or your successor, right? So you need to know every information how you come here, right? So it is this joint distribution says that only. From cloudy, was your ancestor coming to here, the current node, which is sprinkler. This has enumerated this 0.1. What does that mean? It means it is cloudy. What is the probability that it is sprinkler? This represents 0. Only 10% time this happens. What is 0.9 that represent? It represents if it is a cloudy, it is going to rain. It is not a sprinkler. In some sense, it is saying it is going to rain. Right? So 0.9. If you observe one property, sum of each row is 1. Here also, here also, here also, because the probability distribution, right? For rain also, this number, let's say I am telling you what does that 0.2 represent. It says that it is not cloudy. So cloudy event was false. What is the probability that it is going to rain? Which is 0.2. If it is not cloudy, it is not going to rain. That number also intuitively says the same thing, right? So is it clear till then? Then I will go and discuss about this weight class. It is because it's a big table. Okay, fine. Now come to the weight class. As I said, here you can think of your ancestor. What are your ancestor? It could be sprinkler, it could be rain. So that's why here there are two terms. But here it was only one because your ancestor was only one, cloudy. Node's ancestor, not yours. Here two ancestors could be possible, either sprinkler or rain. So this is sprinkler and rain. What could be the combination? It's like a Boolean thing: true, false, false, true, false, true, false, 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 something like that, right? We were interested in knowing about this event, whether it's a wet grass or not. Grass has been wet or not. So, given this priority that it is sprinkler and it has rain, what is the probability that the grass has wet? It is 0.99. This number represents this thing. So, in one way you can think it as a joint priority only, given some information. Given some information, what are the information here? Rain and sprinkler, right? So this is like conditioning on those information, you are calculating this joint priority. So Bayesian network is as simple as that. Bayesian networks are a cyclic directed graph to model conditional dependence. Here you say condition you are doing rain or a sprinkler. For this node it was cloudy. So this is what has happened in the Bayesian network. Bayesian network has a lot of applications, especially in spam filtering, semantic search, information retrieval, and symptom investigation based diagnosis. And I can talk hours on symptom investigation based diagnosis because it's my research. So why this Bayesian network and how it is used here. So given the set of symptoms, what are the likelihood of a disease? So this thing has been modeled using the Bayesian network. Right. You can also read about one of the papers. So it is a knowledge infused disease diagnosis isn't for symptom investigation. So it is a curious paper, you can have a look on it. Now we are going to solve some problem and understand some property of Bayesian network. So Bayesian network satisfies the local Markov property. It says this thing. It says a conditional independence of the non-descendant given its parents. You are here, you shouldn't think about your siblings, you think about your ancestor only. This is the information you need to have. You should not think about siblings. This way it is saying the same thing. Okay. So here priority of a sprinkler given cloudy and rain. I don't care about rain because my route is coming in from cloudy only, so I'll only consider cloudy part. So priority of sprinkler given cloudy and rain is equivalent to priority of sprinkler given cloudy. So this is local Markov property. Don't care about siblings, care about parents. Now, here initially we solved it like P of A given B. Now two events. What is the probability of A and C given B? Because B is the root node. So this is just a multiplication. P of A given B and P of C given B. Now this is the task, this is the question that we are going to work out. This is a very interesting question. A task of modeling a student's marks for an exam. You are going to give an exam, and for an entrance exam, so outcome of an entrance exam is your marks, and based on that marks you either get an admission or not, right? So what factors depends on which you are going to score marks? Let's say there is nothing like a preparation. So your IQ level, how much IQ level you have, and exam level. So exam level could be 0 and 1, means easy and hard. IQ level could be 0 and 1, means low and high. And aptitude score, how much aptitude score you have, it's like again 0 and 1, low and high. And based on whatever marks you will get, you will have the two things, either low and high. 0 for low and high. So an A0 and A1 is high. 0 means you didn't get admission, 1 means you are going to get admission. This was the problem. I am now going to ask questions and how you are going to solve it. I am going to walk out with you. So how you are going to write these terms? P of A M I E S. A is admission. So this term represents you are going to get admitted in a college. A. M, your marks is high. I is what? IQ level. Your IQ level is also high. And E means your exam level. Exam was hard, and S is aptitude score, which is also high. So this represents this one. Is it very clear? Because this is how we are going to express the problem. Now we are going to express it into backward manner. So here last term was what? Admission. So we are going to get admission based on what? Marks. So we are writing here marks. A given marks. For marks you are going to do back chaining again. M depends on what? Exam level and IQ level. So P of marks given what? I and E. What is I? I is the IQ level and E is the exam. Now you have these terms P of I and E because they don't have root node. So P of I for IQ and P of E for exam level. There was one term aptitude score which depends on IQ, so that's why it is here. P of S, your S score given what? It depends on what term? IQ level here. So P of S given I. So whenever you get some question like that, you first try to reduce the last node probability in terms of all others. And it's very easy, you just do backward kind of thing and you're able to do that. Is there any question here from here? This number we haven't calculated, this will be given in the question. Now question will be asked and you have to solve it. So this is the question, calculate the probability that in spite of exam level being difficult, the student having low IQ and low aptitude score managed to pass the exam and secure admission to the university. This is the question, and I have already given this equation. Now someone calculate it and say what is the probability and how this is going to work. Can anyone please try? Swarnim, Nishad. Yeah, please think about it. So it's something very new to you people, so I'm giving you more 1-2 minutes to think about it.
Sir, can you like stop moving? I can't actually
Yeah,
see
sorry, sorry,
the
sorry.
slide.
Yeah.
Sir, it will be point 0.9 times point 0.4 plus point 0.1 times point 0.1.
Okay. Let me note it down. So how are you doing that? 0.9 times.
Point 0.9 times point 0.4 plus point 0.1 times point 0.1.
Yeah, this is what you said, right? Sorry.
Yes, sir.
This is what you said, no?
I can't see sir, what. Oh
Okay.
yes, yes. This is what I'm saying.
Okay.
Yes.
Okay. So why you said like this? Sorry. Why you have said?
Yes, sir.
What is intuition behind these numbers? How you
I,
calculate?
I can't hear you, sir. Your voice is not clear.
I'm saying how you decided this number. How
Okay, sir. So we already know the exam level and the IQ level. So
hmm.
we already know those. So no need to take those probability into account.
Okay.
The marks. So given that the exam level is 1 and the IQ level is 0, which I
Mm-hmm.
assume stands for exam level being difficult and IQ level being low,
Mm-hmm.
the probability is given as 0.9 and 0.1. 0.9 for low marks and zero point 0.1 for high marks. I multiplied these probabilities with the admission being possible, which I assume bit is denoted by A1. So given M0, the A1 is zero point 0.4. So the probability that we get M0 is zero point 0.9, and the probability that we do get admission is zero point 0.4. So zero point 0.9 times zero point 0.4, and then the probability that we get high marks, which is being zero point 0.1, and we'll get admission with with high marks is zero point 0.1, which is weird because I assume that zero point 0.1 assumes high marks and the probability of admission reduces with marks. I don't know what's my problem.
Yeah, so whatever you're saying is reasoning is correct. Let's see whether this is the thing. So,
Yeah, those tables are obviously wrong.
so this is how it is being. So you say A, B. In the question said admission is going to happen. So A equals to 1, fine. M equals to 1, marks is also high. And I equals to 0, IQ level is low. E equals to 1, exam is going to be hard. And S is 0, means score is also less. This is where we are interested, right? So we can write it whatever the equation I have given. If just I put it there, so P of A given M is P of A equals to 1 because the admission is going to happen and marks is also going to happen. So marks equals to 1 into P of M given I and E. So P of M equals to 1 given the information I is 0, IQ is 0 and E equals to 1, right? Into P of I. What is P of I? What they have said already, the guy has low IQ. So P of what is the probability of I equals to 0 into exam is hard, they said. So E equals to 1 into this last term. P of S given I means score is less and IQ is also less. This is where we are interested. Fine till then. Now we have to just see the table and put the numbers. So let's go with this number. So P of A given M equals to 1. So means admission is going to happen and marks is high. Admission is going to happen. This is A of 1 and marks is your high. So this is where this last cell 0.1 we put it here into P of m equals to 1. Marks is going to high. So now come to the marks table. Marks is going to high m of 1. Information is given I0 and E1. I0 and E1 which is again 0.1. We put it here 0.1 into P of I equals to 0. IQ is less. What is the probability? It's 0.8. So 0.8 here. What is the probability exam is being hard? Exam being hard means E of 1 which is 0.3. We put it here. And the last term. Score is low given the information IQ is less. Score is low means score is 0 given the information IQ is less which is here. So first term 0.75. This will multiply, it will come something around 0.0020. Right? So this is how, it's pretty simple. You just need to express it correctly and then you will be able to solve it. Similar question, there is one similar question I'll ask everyone to please do attempt. So this is the question. In another case, calculate the probability that the student has a high IQ level and the aptitude score means high, both has high IQ level and aptitude score. Exam being easy yet fails to pass and doesn't secure admission to the university. Please do calculate in the simple fashion.
So just question like, how is this admission matrix making sense? If one represents high marks, you are saying that the probability of admission reduces.
Where? The previous
So this
question?
admission matrix, one is high marks, right?
One is high marks, okay.
So the probability of admission reduces with high marks.
Where it is?
Before the if the marks is low, that is M0, the probability of admission is 0.4. If the
Yeah.
marks is high with M1, the probability of admission is 0.1. That is, it reduces with marks.
Yeah, this is a given question. You don't have to go into the Abhisek. The priority whatever it is given. You have to look like that. Has anyone done or should I explain?
Sir, I think you should.
Sorry. Should
Yes,
I?
sir, I think you should.
Okay. So this equation is like admission should not happen 0. Marks is also less, m of 0. And I equals to 1 means IQ is high. High IQ. E equals to 0. Your exam is going to be easy, as I said. S is high. Aptitude score is high. This first you need to calculate. And now you need to put it here. P of A equals to 0, M equals to 0. Means admission is not going to happen and marks is very less. So this equation m0 a0 which is 0.6 into P of M given I and E means IQ is high and exam level is low. You go and see here what is I1 and E0 which is M0 for it is 0.5. Now you put it here 0.5. P of I equals to 1 means IQ is high. What is the probability that IQ is high? It's a 0.2. Put it here. P of E0 exam would be easy. What is the probability? 0.7. You put it here. And now score would be high. Given IQ is high. Score is going to high. Where is score? Score is here and it's just going to high 1. Given the fact that the IQ is high means I of 1. This is 0.6. Now you multiply, you will get something around 0.0252. So this kind of example is which you may encounter in your exams. Right. So please be followed. Any question it out till there?